design in the assembly. Weight reduction. Yeah, anyway, we'll see the part consolidation means I have, say, you take this, at least it may have some 10 to 12 parts which it has been assembled. But additive manufacturing can make this as a single setup, single product. So all the 12 parts made it as a single part, and in a single setup you can print it. So anyway, we try to see some case studies, this part consolidation and the tooling. So injection molding, you know? Yeah, then how do you design a mold? Huh? So have you heard about conformal cooling channel?
Yes, sir.
What is that?
In drilling, we can drill straight holes only. By additive manufacturing, we can use the spiral shapes.
Yeah, very good. Exactly.
Around the mold cavity type.
Yeah, then what is the advantage?
So we can get the cooling effect on the surface of the
Yes.
complex surface.
Yes, means you are going to get the solidification is uniform,
Yes.
and the errors will be minimized, and the die life will be increased.
Yes.
Okay, anyway, we'll try to see some design guidelines in the tooling, right? And you have polymer printing and you have metal printing, right? By this time you might have exposed not only metal, even you can print composites, even you can print ceramics also. Anyway, we'll see some design guidelines. This talk purely on the design aspects. Next talk will be on the biomedical applications of additive manufacturing, and this talk predominantly on the design aspects. And build simulation, and finally what are the challenges of AM. So this is what the talk is all about. But anyway, you know, what was the first industrial revolution? Huh? Automation? No, automation will be second industrial revolution. The first industrial revolution? Mechanization. Yeah, very good. So mechanization, right? So means you have machines. So your human muscle power has replaced with the machines. That's what mechanization has come during 1780s to 1860s. Means you have only steam power. That's what James Watt, that's your steam engine, right? And you have only the steam or water power, right? But coming to the second industrial revolution, where you have assembly lines, and your water, steam has been replaced with the electrical power. That's what second industrial revolution, right? The third industrial revolution, if you see, that's what where your computational IT, information technology has come into picture, right? And you have automation, electronics, that is during 70s to 2010. So you try to see the time phase from first to second industrial revolution. So almost it took, say, 90 years, maybe 80, 90 years, and similarly for the second to third, it may be again 60 or 40, maybe more than that. And if you see that 3 to 4, it is hardly 14, or now people are talking about industry 5, even industry 4 also outdated, industry 5, right? So what I am trying to say, so your technology is evolving very faster rate, right? So that's what, then anyway, right now you are talking about industry 4, you have autonomous systems. What are the autonomous systems? So driverless car is an example, right? So which it can, and then you have a cloud computing. Now you don't have physical servers now, everywhere you have a cloud-based computing, right? And you have a system integration, simulations, IoT, Internet of Things, right? And you have augmented reality, virtual reality, AR, VR, right? And you have a big data. Now you have, the data is huge data nowadays you are handling, right? So you have big data and then cyber security. So the biggest threat is like everything is digital, somebody may tamper or somebody may, yeah, then you must have some kind of say protection for that. Anyway, you have a cyber security kind of concept. So okay, everything is fine, then who is going to manufacture, right? So that's what your additive manufacturing is going to play a major role under this industry 4. So you have AI, but AI will generate a lot of ideas, right? But who is going to manufacture? Idea is not the destiny. Idea is only the start point, concept is only the start point. Then somebody has to fabricate, somebody has to manufacture. That's what additive manufacturing is going to play a major role under this industry 4, right? And this technology is not a new, probably you might have heard about this term, rapid prototyping, right? So when it was started in late 80s or early 90s, 1989, 88, 89. During that time, used to call this technology rapid prototyping. So means the application may be limited to only prototype. That's what it used to call as rapid prototyping. But now it has been mentioned to manufacturing level. Right? So the prototype is a designer tool, but additive manufacturing, you are saying it's a manufacturing tool now, right? So yeah, now it is almost from designer to manufacturing. It is coming. Why? Because you can make any complex shapes, and that too you are using it as a direct product. You are making some aircraft engine and directly you are fitting into the aircraft. It's not a prototype, right? So that's why it has been elevated to manufacturing. From the prototyping to it has been elevated to manufacturing. The technological advancements and the maturity of this technology has gone to a manufacturing level. And in a common layman term, it is 3D printing. You know 2D printing. 2D printing. You have inkjet printer or laser printer. What it will do? So it will print on a paper. Basically, it's a 2-dimensional printing. But now you have a 3rd dimension, right? That's the 3D printing. So whatever you call this technology, either you call additive or either you call 3D printing or you call rapid prototyping, but the essence remains same. What is that? What kind of input we need to give to this technology? Yeah, it's basically a digital data. So a digital data, it may be a CAD like this, or it could be a reverse engineering or a digitized data. You may be knowing reverse engineering or 3D digitizing, right? So where you have the 3D scanners, so you have a physical object, and just you scan it, you will get a soft copy. Something like your domestic scanner, a document scanner. What it will do? So it will digitize, but that is in 2D, but now it is in 3D. So even you will not model it right from the scratch. So you have a scanner, you have already physical object. Why again you need to go to CAD software and do it again, right? Just you scan it and you get a digital or CAD model or a digital data, right? So, and this is CAD. Through CAD you can get a digital data, or through a reverse engineering or a 3D digitizing system you will get even a soft copy, or from the even medical applications you have a CT. And again the big revolution in the medical diagnostic system is again a personal computer. That's what you have, CT data or MRI data. So everything is a computer imaging. So no X-ray, hard film, right? So that again the impact of computers. And in the medical also you will get a digital data, that is a CT or a MRI scan data, right? So then that can also be the input. So it need not be an engineering area, or even it could be a product designer area, or even it could be a medical, or even it could be anything that you will get a digital data. Maybe entertainment area, or maybe some other area where you have a digital data. So then you can start your journey, right? So means you take a digital data. So you want to make any product, you get the digital version, digital copy of that, right? And then you print layer by layer anyway. So your input is a digital data, maybe CAD, maybe a reverse engineering, or maybe CT, MRI, or it could be anything for that matter. So then quickly you can make physical products without writing any code, right? Anyway, we will try to contrast CNC and the additive manufacturing. And if you try to classify the manufacturing systems, as we know, everybody is talking about CNC. That's basically CNC, the subtractive manufacturing process. So already somebody has said that there will be a lot of wastage, right? And this is not meant for very complex objects. Yeah, you can do it, but it may take several setups and 5-axis CNC machine. And that also we need to do a lot. Sometimes we need to design a fixture. You need to design a say jig, right? But anyway, so subtractive manufacturing, if your product complexity is high. If it is simple, you don't much worry about the subtractive. Okay, you can go. But your complex, why? Because now you are talking about bionic designs. Now you are talking about topology optimization. And even if you take a simple coffee cup, so in order to machine this, it's very tough, right? So imagine that you have a block. From the block, you are trying to using some tools and removing the material, right? So then you have this cavity is too deep, and we need to check what kind of a tool. So we need to do a lot of exercise in terms of tooling and tool radius compensation. So all that we need to do a lot of things, right? And you have undercut here, and you have a sharp internal feature here. So then we need to see several constraints here. If it is once you change the complexity from the simple step to a free-form surface like this, right? But in case of additive, what you are going to do? Just you are adding the material. So then what is the big deal in adding the material? And your complexity now it has been reduced in 2 dimensions rather than a 3 dimension. In CNC or in subtractive manufacturing, always you take a 3D block. Yeah, always you will be working with 3-dimensional complexity. But in additive manufacturing, always you work only 2-dimensional, 2.5D in the some thickness of the layer. Always you work with only 2.5D complexity. So means your 3D complexity has reduced to 2.5D complexity. That's what it will be very easy to make any complex object. That is the secrecy, right? Anyway. So and then you may have the other kind of manufacturing system is a formative. Can you give one example of formative? Huh? Forging. Forging? Casting? Yes. So in case of a formative, you make a mold or a die, and then you inject the material or a billet, and to confining to the shape of the die. Exactly whatever the component that you are looking at, trying to get it, and you make that die of that shape, maybe in 2 halves, right? And again, how do you make this die? How do you make this die? Again, you may go to the CNC. But again, the same story will repeat, right? So in a single word, additive manufacturing, it is a toolless manufacturing and it is a die-less manufacturing, right? Yeah. And then what about cast? The cast per unit